So I'm going to talk about this project, about getting information off of social media and into the right hands. What this project is our attempt to take a sort of approach which is called social sensing, and take it to decision makers who can hopefully apply it in their domain and get it out of academia. First thing I'll do is describe what social sensing is, so you have an idea of why anyone would want to use it. So it's kind of a trivial observation that you can detect events by observing people's reactions to them, right? You can tell it's raining there because everyone has stuck up their umbrella. When we look at sort of social media, which is where a lot of interactions happen, you can also see people's reactions to events there, and we can train the computer to recognize those events and tell us about them. So one of the simplest things that people do is they try and solicit people's observations. So there is a group in the Met Office who encourage people, whenever they see snow, to tweet with the hashtag UK snow. And they take those observations and they stick them on the map, and you get some sort of picture of snowfall in the UK. There are other agencies like that. There's another Met Office initiative called WOW, which encourages people to give more detailed weather reports. There's something called the European Severe Weather Database. There are people with their own weather stations that they keep in their back gardens, and they hook them up to Twitter, and they tweet every 5 seconds about the atmospheric pressure in their back garden. But with all of these things, the problem is basically the volume of data. You can't really rely on people to use your hashtag. You can't rely on it to have any sort of staying power. So it's better to just look at sort of unsolicited messages. Just observe what's happening already without trying to affect people's online behavior. So in order for a sort of event type to be able to be socially sensed, these are sort of 3 good things to keep in mind. That the event has to be somewhat significant. So a flood, an earthquake, a landslide, people are going to notice that and they're maybe going to mention it. But for example, rain in the UK is almost impossible to socially sense because people don't really talk about it in the sort of event, bursty, significant way that they talk about other phenomena like floods. It should also be spatially banded if it's happening across like a huge area. You can tell it's happening, but we can't really say much more. So it's very useful downstream if the event is localized. It should also be temporally banded. So if it's persisting for months and months, people are going to lose interest and stop talking about it. So landslides happen quickly, oh my god, and then people tweet and then they forget. But something like hay fever, which we've tried to socially sense, produces a very different signal. It's much more stretched out. You can still see it, but you maybe can't use it in the same way. So these are sort of the basics of social sensing. And I'm showing you this sort of Japanese website. So this was one of the first applications of social sensing. So they used Twitter and they searched on Japanese language tweets everything concerning earthquakes, and they were able to detect about 96% of all earthquakes in Japan, and they built this little warning system which was actually able to alert people outside this sort of epicenter faster than the Japanese meteorological agencies just by using tweets, because apparently tweets travel faster than earthquakes. So you would get a little text and it would tell you a shockwave was coming. So one of the interesting things is the date column on the left. You can see that they're all tweets from 2009. So basically this is not new technology. It's something which has existed for a long time and has already sort of been demonstrated to be useful, but it's not really been taken up too much in the forecasting and sort of early warning institutions and agencies responsible for this kind of thing. So that's kind of what this project was about. It was about trying to get this technology into the right hands. So the project. initially, our idea was to take this social sensing thing and make it like an app or something, and then give it to people, and they would use it, and they could see, oh, look, it's flooding today in London, I'm not going to go there. But when we started talking to the National Flood Forum and people who were involved with people's actual responses to floods, you know, they basically pointed out to us that everyone has enough apps, no one's going to look at it, and it'll be very hard to, you know, it'll be mainly a marketing operation. So we decided to instead work with some institutional partners that we already had some links with. In this case, a group called the Flood Forecasting Centre. So the Flood Forecasting Centre are a group that work in the Met Office. They're a group of what they call hydromets, hydrologists who are meteorologists or vice versa. So what they do is they aim to provide this thing, the flood guidance statement, which is supposed to be the best document for flood risk in the UK over a 5-day period. So they have these maps, they have their sort of short summary, and they also have a little risk matrix here, which I'll come to. So this is uncertainty / risk, I guess risk in this sense. They have their own flood risk matrix where they, you know, have 2 dimensions, as we've seen before, likelihood and impact, and you know, they make a decision on what to warn based on, you know, the sum of those 2 dimensions. So the Flood Forecasting Centre, alongside producing this flood guidance statement, which goes to the Environment Agency, emergency services, utility companies, all the way up to Cabinet Office, I believe, if there's a very severe flood event. They also have a person on call at all times who's sitting in front of a bank of monitors, looking at the rain radar, looking at river gauges, you know, who has a phone, who watches flood events as they unfold and notifies the appropriate person if necessary. So they also do certain verification tasks to see how good their flood guidance statement was. And if you're like me, though maybe you thought the Met Office was all about lasers and radars and satellites, but what they actually do is, if they forecast a significant or major event, after the fact they will go back and look at a bunch of websites to see if there was a flood in that area. And as you can imagine, this is pretty tedious to do. So they only do it when it's a fairly significant event, in which case it's likely to have generated a news story. So their verification exercises are not necessarily top priority, and when they are done, they're done in this sort of ad hoc way, which is time consuming and no one there enjoys doing it. So talking to them, our aim with working with them was to basically help them produce this flood guidance statement, help them improve their processes, and help give them another view on unfolding flood situations. So we wanted to build firstly, they were mainly excited about getting all the tedium out of their lives by having us condense all the sort of disparate websites that they go to do their verifications with this fancy all-in-one social sensing platform. When we showed them a sort of mock-up, they also said, okay, well, this could sit alongside the rain radar and the river gauge, and we could watch it, you know, in our monitoring tasks. So basically, that was the plan. Work with them to produce something which would help them in all their decision-making, help them in what they do already, which is kind of the aim of data science too, which is what I am supposed to be. Condense a ton of information into a sort of digestible form, and so that people can actually use it rather than it just being disparate on the internet. So how social sensing is actually done, I'll give you a very, very brief synopsis. So we're looking for stuff like this. We want to collect as many of these as possible and then put them on a map. So the way we do that is to tell Twitter, give us all the tweets you have containing words like flooded, flood, flooding, floods, that kind of thing. So you get an awful lot of social media posts. On a very floody day, you can get 250,000 posts just about flooding. So you have to be able to handle that sort of volume of data. So you have to be able to process everything very quickly. And a good way to process things quickly is to not process them. That's probably the fastest way, actually. So we try and filter out as much as possible. So we have robots tweeting about floods. They are very, very, very active. They generate a lot of posts. They will update you on the level of a river every 2 seconds or something. They are quite easy to identify, so we identify them and remove them. We don't really care about retweets. The online social network is a very interesting thing to analyze, and that's what I do the other part of my time. But at least in this case, we're interested in direct observations of flood events that people, I have observed a flood and I've reported on it. I don't really care about the conversation after that. So the number of retweets you get is a function of your social status, your popularity, not really your accuracy as a flood reporter. So we filter out all those as well. Then we get a whole bunch of stuff like this. We get a lot of obviously garbage tweets. The market was flooded, floods of tears. The flood of immigrants is an incredibly common thing to get, unfortunately, for me as an immigrant. But those kind of things tend to be quite easy to filter out just with manual, you just read enough and you know the kind of things, and then you delete them. We've also got some more subtle things like flood defense works. Someone's bathroom being flooded. The difference between that and the kind of thing we want, like the road to Exeter being flooded, is more subtle. So in order to deal with those, we train a computer to do what we do when we read those tweets and determine whether they're relevant or not. So we basically have to classify a bunch of tweets as sort of training data, feed it into this sort of machine learning system, and then it comes back to us relevant or irrelevant, basically. So it does a pretty good job. It gets it right about over 80% of the time, so we lose some data there, but we have to lose data or we'll never be able to process everything. So then we have to figure out where everyone's tweeting from. So most people don't GPS tag their tweets. Very, very few, and they're mostly very, very few people do that. And a similar fraction say, it is flooded today, tweeting from, London, Exeter, or wherever. So what we mostly have to do is analyze the sort of metadata. So people will tell you where they live, and you have to learn to read that and turn that, reverse the place name and turn it into GPS coordinates. So basically, we look for places in the user location field and places in the text. And then we basically have huge databases of place names. It's called a gazetteer. It's like the reverse of an atlas. You look up a place name, it gives you coordinates. And then we combine those with big lists of the most common words, UK postcodes, UK towns, and so on, to try and extract as much location information out of each sort of utterance as possible, so that we know where everyone is tweeting from as accurately as we can. Then we do some verification. This is a sort of ugly slide. This is an example of social sensing 1.0, ugly maps, but we'll get to 2.0 in a minute. But the basic outcome of the verification step was that we managed to collect all the flood information that the Met Office currently does with their sort of ad hoc procedure and more. So that's great. In case you're wondering about this, GDPR is European Data Protection Regulations, and even if you don't have direct experience with that, you have to click a lot of cookie consent buttons nowadays. So we are mostly using public Twitter data. So we are under the impression that as long as Twitter is GDPR compliant, so are we. We're not really using anything that isn't publicly posted, that any random anonymous person can go and look at. Like if you tweet, it's flooded, anyone can see that, so could we. We take that tweet, we say, this is where you're tweeting from, because you've told us it's flooded in Exeter, we put your pin there. One thing that did happen in the middle of this project was that in order for Twitter to be GDPR compliant, they deleted one weird piece of information that we found very useful, which was the time zone that you tweeted from. So you can imagine if somebody says they live in Cambridge, that might be Cambridge, Massachusetts, or Cambridge, UK. So the time zone was kind of a nice piece of information which let us disambiguate those two places. But we sort of work around that by looking at other pieces of data. This is what we built for the Met Office. So this is a map. As you can see, there are settings which you can change. Let's look at this one for the minute. This is static on a particular day. When was it? 15th of October. So about a month ago, there was a big storm called Storm Callum, which caused a bunch of flooding. And this is what our tool showed the Flood Forecasting Centre on that day. So there are lots of different layers you can look at. Well, not lots, but some. This just shows a colour map over England and Wales, where the stronger blue indicates more tweets about flooding. So you may consider that 100 tweets about a flood in Dartmoor is a lot more than 100 tweets about a flood in London, because more people live in London. So the layer that we mostly look at is this one. So we have a historical database for every county of how many tweets we observed on a given day. So essentially, the sort of redness reflects the 1 in X days. So dark red is something like 1 in 200 days, so it's a fairly significant number of tweets, indicating probably a fairly significant flood. We reported as, if I hover over there, a number called an exceedant probability, which is what meteorologists apparently like. We can click. There we go. So here's some Devon. Devon tweets on that day. There's one. Storm Callum flooding, the 6-foot hole in railway track. So this is the kind of information that the person sitting at the desk with all the monitors can maybe look at. They can look at different views. They can have a coarse grid. They can have a finer grid. They can also look back historically. If I do this, it's quite nice. You can sort of see before the storm, and then as the storm unfolded, you see sort of basically Wales, South Wales was most heavily affected. So that is the demo of our little tool. I'm shocked that it worked. There's also a live version. If the computer on my desk in my office is still on, this will work. There we go. So this is flood information for today. I'll click on Devon. Again, so you can watch the sort of all the flood information that we could extract from Twitter here in this little display. Basically, we built this in consultation with them after a lot of back and forth, sort of iterative development process, which if you're in the software world is sometimes called agile development, which means you don't just hide and then do something and then give it to them and then run away. You do something, show it to them, they complain, you fix it, etc., etc. So here are some internal Slack thing to prove that people actually use this in the Met Office and they seem to like it. So that's great. So basically, this process was kind of interesting. Maybe I'm too much of an academic, but essentially what we found was the people in the Met Office definitely had the technical capability and the technical know-how to take our research code, run it and look at it. But they had no time and they didn't want to do that because it's not their job. So we couldn't just, we tried to, believe me, just dump a bunch of code on them and let them figure it out. But in order to actually get this thing running, we needed this sort of long development process, consultation, back and forth, iteration, and so on to make sure that we were, making something that they could use. And then even once we had finished, they don't want the tool to be handed off to them. They want you to continue to manage it. And often they're not really even institutionally capable of doing that. Like the Met Office has a lot of issues around security and stuff. They can't just take random code and run it internally. So basically, as a sort of data science, computer scientist person, the way I think that we can best help with managing risk and uncertainty is to, approach institutions which already have processes in place for dealing with risk and uncertainty and see how we can help them improve those processes. So in the Met Office case, for the Flood Forecasting Centre and for a lot of other people we've talked to in the Met Office, often this verification task is really tedious to them. So by improving the verification process, we can help them improve their models, improve everything, streamline their process. And in order to do that, we found basically you have to spend a lot of time talking to them, building a relationship with them, showing them that you're actually going to, you're receptive to what they say, and you care about their problems, and you don't just want to apply the fanciest method that you can do and then run away. So yeah, consultation and iteration, and this sort of what in the software world is called agile development, but what in the real world is called talking. Is essential. So, that's all for me. Thanks.